discharge. It becomes ionised. So some atoms get excited and they lose an electron, and thereby the atom ends up with a positive charge, and vice versa, you get negative charges. So you've got this charged air, some positives and negatives. What we are going to do is to, in order to demonstrate that ionisation of the air, we're going to, and how that's influenced by changes in those exposure factors, we are going to use this electroscope. And this is a bar, copper wire, and look down there. It splits at the bottom, and there's a, I can't think what to call it, it's like a filament.
So does it swing like a pendulum?
It does.
So
a pointer, thank you.
A pointer.
A pointer. So what happens if you can transfer with your magic wand made of amber, and this is wool. If you rub this very vigorously, and I don't want to hit any jigs about it, you can transfer, the electrons are rubbed off of this, and you can impart them onto the copper wire. This is really interesting, because sometimes it works, and sometimes it doesn't.
That's the least reliable bit of equipment in university.
Oh, there it goes. Yeah. So, because they're both the pointer and the bar are negatively charged, they repel each other.
Yeah.
Hence that. So you can carry on.
So by touching the static charge,
Yeah,
that makes the whole thing negative.
Yeah, it transfers electrons from the amber bar.
Is that just because those
that.
become negative, just as a lot of their
Yeah, that
properties?
becomes negative.
So if it was another piece of equipment, it would be positive. So if it was another piece of, I don't know, cotton or something that you're rubbing on it?
No, we'd always be transferring electrons
Okay.
and making this negative charge. And it builds up. So what we want to do, and this it irritating me, the swings for ages, but we want to get it so it's fully charged. It's not a very precise thing. And there's a lot of variability between people who got the touch today. It wouldn't do anything on Friday, so I don't know quite what the difference is.
The group you demonstrated in front of.
It's the magic we've got.
Yeah.
It's the magic grouping, isn't it? So there we are. I think that's probably going to settle at a suitable level.
How does it swing so much?
I don't know, but it's looked. Sorry, can I just be quite large? Really large.
Where's radiation on that as well? Those things that measure radiation.
The badges,
Yeah.
yes. Yeah,
Okay.
you'll have to wear those when you're in the X-ray room.
Okay.
Your badges.
On a sign, does it?
You'll go in pockets. Come
That's
in,
cool,
you
isn't it?
take
That's
your
cool.
own. There's mine. Hardly ever use it, but there it is. I will just charge it up a little.
That was a huge thing.
Right, so when we pass X-ray through there, it will ionise the air around it, and because the ionised air has both positive and negative charges, the flow of electrons will be away from the electroscope into the ionised air around it. So you can gauge how ionised the air is by how quickly the electroscope discharges. So when it discharges, the arrow will go down. So all you need to do is pass an X-ray through there, and then time how long it takes for that to discharge. And you'll do that first by changing the KV and then DMA, is that right? Over page. Yeah. So for the first one, you'll set a constant current of 1 amp, and then change the KV, and then reverse it round for the second one, and see how that affects the ionisation of the air. So we'll shut that. Lock it.
Is there a timer, or are we doing that phones?
Oh yeah.
There is a timer, but it's unnecessarily complicated. You find it much easier to do it on your phone. You only need it to do it to the second. near a second. So, sorry, what did we say? 1 MA to start with.
Yeah.
1 MA, 5
Five
kV.
Yeah.
I mean, could we go down?
Could we go below?
Huh?
Is that from 5 or 1?
1 million. 5 kilovolts. You say, could we just go down just to say, we're at 35.
Actually, I'm going to suggest you start there and work that way, because at this level it was taking so long for the electroscope to discharge that we ended up running out of time, so better to
Up to 50.
go that way. So you want to take it, note where the pointer is, and when the start your stopwatch at the time when pointer is at that last
Yeah.
terrible trouble with my vocabulary segment.
Yeah.
You know what I mean.
When it stops.
Yeah, in fact it's almost there now. So we've got our MA at 1
So a kV at 50.
and we set our KV at 50. So what am I doing? Voltage.
You don't even regret going out.
50 did you
That's
say?
cool. Yeah.
50.
Oh,
Max 35?
Max 35
Huh.
then.
So we can line
That
up
sorts
now.
that out.
Oh, so we can't even do 50, 40, 40.
Just line them up. And then
Good.
Okay, so you're ready to start timing?
Yeah.
Because it's going to
As
go
soon as you push the
from
button or as soon as the
now.
light goes on?
So turn that,
Oh,
do we?
no.
35,
So is it now or as soon as the light turns on?
and then you press that, and away it goes. Ready to go?
Yeah.
There's a bit of a time lag between, there it goes. So you probably want to start the timer when that goes red.
I'll say about 9 seconds.
I'm not gonna lie, I was expecting like coruscating light or something.
It's all much more pedestrian than that, isn't it?
Should I stop and you reckon?
Not yet. Not yet.
Is it to the?
Yeah, to the very last one. Now. Now
Yeah,
stop.
stop.
56.95, but that's including warm-up time.
-9.
Is it -9?
Yeah.
57.
Yeah?
To 47.95?
Yeah, 47.
Okay, so now just follow the instructions and change in your variables. And leave that with you.
Wait, are you on?
Yeah. You might find some of you can actually get a charge of that and some can't. So yeah, if you want to, you shouldn't need to, but if you need to work it, just put your finger on the ball at the top and it's interesting.
I thought it was going to be like rapid.
Yeah.
Zoom. I thought we were going to have to say, oh, we missed it, then have to do it again and stuff.
Still up.
Yeah, it's still up.
Still up. No, no.
Somebody's going to have to stand around that, aren't they? It's going to be me, isn't it? See now.
Oh, man.
Yeah. This is the
Not gonna lie,
Somebody's going to have to knock.
semi-disappointed.
Yeah.
I have a list of answers
Oh, okay.
and stuff, so I'll see if you're on there. They would let you
I
know.
normally am. I normally do the secondary ones. Thank you. So we're going to pop this data as well. I'll let you write it down first, mate. Otherwise you won't have anything to look.
That should be alright.
Yeah.
Boy.
Yeah,
that's probably sweet, you know.
Yeah, okay.
Yeah.
Just twist it, that's the job.
Yeah.
I heard about that Robin life, you know what I'm saying?
Yeah.
Set an M10 up.
So yeah, so you can do it right now.
In electronic form. Leave mark.
Wait, no, is it? Is it?
Ready?
Yeah.
Cool.
Where am I?
5.
Yeah. God, who am I doing? Rachel. Well, that's second year. No, it's not Rachel. Claire.
Which is the second
Score.
Oh, this is slow.
That was the first and the second one. Okay, so you can open a new spreadsheet, or you can just click the plus button down the bottom left to see your Excel spreadsheet. And it'll open up a new sheet. So just like before, you're going to plot number of rows, one column, and the
So
remaining.
the other way, isn't it?
The first one was right first, I think.
Really cuts it out right to the end, didn't it?
Excuse me.
No, I'm cool. Yeah.
I'm off to
Wow.
the second year.
Yeah, it's
Well,
fine.
1482, so
Huh?
109, 109.82.
Project. Makes down practical. It is helpful,
Oh.
69.82.
So you never actually got down to zero, is that true?
Yeah, no, it's not. Skip. Alright, sure.
Well, just to ruin it slightly for you, if you got it out but don't include zero, that's it.
Charging at point?
Yeah.
I
Got it
reckon,
down,
It's
haven't I?
absolutely correct.
I reckon we've got the best practical week.
When you come to the plot.
No, no, you got it.
Apparently beards are good.
Yeah, just go down to 26, then to 27. And what you're going to plot
Oh, right,
is
Gotta be.
number of
Yeah,
people
definitely.
against, that's on the y-axis, against the number of throws outside.
You reckon we need to earth it? Ooh,
Oh, right down to
I had
the
that
bottom.
Are you-
fully answered.
Are you
Went
struggling to
straight.
get it at the right
Yeah.
Yeah, we
point?
got it right up to the top.
Yeah, I see the problem. Fully charge it, and then as you fire, it's slow enough in discharging that you can just be watching it and
Zero up
then
there is fine.
press your
Ah, yeah,
timer
makes sense.
button when it hits the
Then go to insert.
Yeah.
Oh,
whatever the
yes.
word
That
is,
makes sense,
gradation
yeah, yeah.
thing.
So,
That's good.
So otherwise,
we're gonna be here all day.
yeah,
aren't
you would be
again,
there all day.
click on the plus.
You will notice there's a question, there's a series of questions there, and it asks about areas of potential errors. So that is an area of potential error, is getting your timing, but you're not doing it to the split second. But you know, these are the sorts of things that you want to be
we?
writing
Strips
up.
and limitations and stuff.
Yeah, so you'll find that there's potential error there. You know, there's a time lag. I don't see why that should actually cause you an error because you're not timing it till the X-rays start. But you know, there's a bit of variability there.
Okay, right to the top.
Yeah. Oh.
Oh.
So how could you reduce your timing on the error on the timing?
You do more precise timing methods. I mean, you use the one built into it. We tried to figure it out, but it said parameters and mode and things like that. So,
I didn't even notice there was a timing on
it's
that.
like right here. I don't know if you can figure out. So parameters for on.
You see?
Oh,
It's not
like
gonna
number
have a
of
spirit of
seconds, isn't it?
adventure, but
I just don't want to break it.
yeah. Just plain use.
Okay.
Maybe that'll do.
So now
So we
you
need it
can
on
just
25 now.
Oh my gosh! Imagine how slow it's gonna go.
Did we change it as well?
Yeah, 25 volts.
That is locked right.
Kilowatt, yeah.
Menu. Actual parameters.
40.
Voltage 25.
Yeah, yeah.
Okay, so. Let's get it back. This one.
Drawn forward in a moment. It's an exciting moment. I'm going to use technology. Oh yeah.
No?
No, look, it's one more.
Ah, you're right.
Okay.
Is it warming up?
Where's the time now?
I don't know.
So
I
wait
think-
until it goes to the
Yeah.
first point, maybe?
Like
think
every
so,
10
countdown.
seconds and stuff.
No.
What?
You just did it for 10 seconds?
Oh,
Oh,
I was just trying to-
bro, that time I done man over. Get rid of that time, man. Get rid of
Get
that.
rid of it.
Get rid of that. Quick.
Just get exposed for 2 minutes. This is
No,
half
we
an hour.
got time.
Oh, yeah.
Today,
I know.
5?
No idea.
Start. Maybe. The 5-second delay. Yeah, there we go. 2 minutes on the clock. And then just measure when it starts.
So when does like the 2 minutes start to order?
So now we're on 1 minute 50.
Now,
1 minute 50 now.
now?
Yeah, so 1 minute 50 and then see the difference. Try that.
Oh, okay, let's see. Oh, fuck, bro.
This is going to be the worst YouTube video ever.
Can you edit the videos before you put them on?
Probably.
I'm trying to be edited out.
Well, not edit it out, but just speed it up.
Yeah, because there's a lot of pauses.
Video will be about
Yeah.
half an hour.
I figured out how to use timer.
Yeah.
Figured out how to use timer.
Oh, have you?
Yeah. We just set it to a certain time of exposure,
Yeah.
and because usually that's quite a lot less.
Oh, is that the exposure time for the X-ray though?
Yeah, I hope so.
Just carry on as you were anyway, so oh, we get into the long, slow.
Yeah.
Decay constant lambda. So the decay constant lambda is in your equation. So the equation at the beginning.
So I think for the next one we have to do a 3-minute exposure because that one took ridiculously long.
This is the number of everything. Start with
So a minute 20. So that was 1.5.
27.93.
127.
How long was it?
So it's 87